Hello again and welcome back to our series of Valodrin tutorials. Today we have another very cool project for you. These are some parking sensors that we're going to create for ourselves. So what we've got here are 8 LEDs which I'm going to control using this distance sensor. I'm going to be using this one later, but first I want to show you how you can use multiple LEDs using a shift register. Okay, that's this one in the middle. And that one is a 595 shift register. Okay, so what's happening in terms of connections here? I've got 4 LEDs on the side connected via these 4 resistors to each one of the bottom 4 pins of my 595, and then I've got the other 4 LEDs connected here. As in previous projects, I've cut down on the number of cables by using the ground pins of the LEDs, those are the shorter ones, connected here to my ground row, which you can see is connected to the ground here on my Intel Galileo. This ground is also connected to the ground pin of the of the shift register over here. It's also connected to this 5-volt line here, which goes to this pin of the 595 as well as the next to last one. Other than that, we're using 3 pins for the data, shift, and latch pins here. Okay, back to the interface now. I'm going to create another application called Parking. I'll make sure it's a new project under Visual Programming. Hit Next and Submit. Then find its name Parking and click it here. So the first thing we're going to do is we're going to learn how to control 8 pins using a shift register. We don't need to print anything on the screen for now. So first of all, we need to decide on what value we're going to need to send to this pin register and learn how to do that. In order to send data to a shift register and have it process it, first of all we need to set the latch pin, what's called the latch pin, which is set on my pin 5. We need to set that to low. So under peripherals and pins here, I'm going to set pin 5 to low. That way we can send data to it, so fill its memory bank. Then we're going to shift out data on my data pin, which is pin 3, and using clock pin number 4. So these are all nicely back together, 3, 4, and 5. Now the value is the most important thing we're going to need to send. So to do this, I'm just going to create a function. This will have to return something, so I'm just going to call this get data to send, and it will have to return a variable, which I'm going to call LED. Because of the number of the LEDs, it needs to start. Because of the number of the LEDs, it needs to start. Initially, I'm just going to go through the LEDs and turn them on one at a time, with the previous ones also staying on, so you can actually see the values which are being registered there. After we do this, we're going to have to set pin 5 to high, so that actually commits the change that I performed. I'm basically going to add this in a loop to start off with, so repeat every second. I'm going to run through the loop 9 times, so go here and repeat it 9 times. Add everything into the loop here. Initially we want to set a loop variable to 0 before we do anything, so make sure you do that. After we've done this once, we need to upgrade the pin variable by 1 so that the next one starts up as well. So go under Numbers and Maths and hit Change LED by 1. Then we also have to add a slight delay so that things don't happen way before we can see them. Okay, that's basically my main loop for controlling it. Now we need to figure out which data to send. If we'd just like to light up the first LED, we have to send 2 to the power 0, so that's number 1. In order to start the second LED, we have to send 2 to the power 1, so that's number 2. However, if we would like to start both of these at the same time, we want to also send 2 to the power 1 plus 2 to the power 0, so that's 3. And if we take a look at it, 3 is actually just one number short of 2 to the power 2. And that's always going to be the case, no matter how you look at it. So basically, if we want to sort the first n number of LEDs, we have to go 2 to the power n plus 1 and subtract one digit from that. So basically, I'm just going to add the value getDataToSend from our function here. So the value will be this getDataToSend, and this LED variable will be the one that we return. So I'm just going to add this getDataToSend here, and what our getDataToSend will return will be a new variable called data. Okay, so let's rename this variable here to data. And the way we're going to generate this is by going here and selecting 2 to the power 2 to the power. Okay, so grab one of these digit blocks. Here, calculate 2 to the power. We're going to have an input here, so add this under input. Its name will be level. Okay, copy one of these variables here called level. So it will be 2 to the power level minus 1. So we have to add another block here, insert this one here, and then subtract 1. Okay, and now we just have to return our variable called data. And there you have it. I just need to add this quick variable LED here. Now what's going to happen here once I run it is the shift register will turn on as many LEDs as I instructed it to. So it will go from 1 to 2 to the first 3 to the first 4 and so on. The distance sensor requires 3 cables to be connected. One of them is the ground pin, the other one is the 5-volt pin, and the last one is the analog input. So according to my specifications, I've got the black one that's connected as the analog input. I'm going to put it here on pin A1. Make sure you notice that A1 is the second one in the order, as the first one is pin A0. Okay, my red one has to go here to the 5-volt connector. Any place on that row will do. And my orange one has to be the one connected to the ground, so I'm just going to put it right here next to the other ground pins. Okay, let's see what's happening in the application now. The first thing we have to do is add a variable which will get our sensor data. So I'm just going to set some new data here after the opening of the loop. I'm going to create a new variable here called sensor data. Sensor data. And we're going to do an analog read, so go to pin access here and go to and add an analog read on pin 1. The next thing we have to do is to send a signal so that we're actually able to monitor that the results we see on the LED are correct. So go here under signals and send a signal with a certain value. Let's call this one proximity, and its value will have to be our new variable, sensor data, which was added here. As we don't need these LEDs to only happen 9 times, I'm going to delete this loop for now and just connect this here. Our levels are going to change based on a new function, so I have to create a new function here which will return something. It will be called getLevel from the proximity sensor basically with, and then I'm going to add an input for it. Its input will be sensor data, and it's going to receive basically the sensor data that we get from this variable. Okay, so apply the new function here just so we don't forget. get data to send with level, get level with sensor data. Now we just have to add this sensor data and get the correct level, and we're good to go. We also have to delete this slight delay at the end and get rid of the change LED instruction here. What we're going to do in get level, basically set a new variable called LED level to a mapping based on 1023 going from 0 to 8. Okay? First of all, we need to look at what sort of data we get from the proximity sensor. So I'm just going to assume it goes all the way up to 1023, but that might not be the case. So anyway, I'll need to have a mapping. So LED level will basically map our value from sensor data. 0 will go to 0, and then 1023 will go all the way up to 8. This way, we're basically simulating the experience we had last time, where all we had were values from 0 to 8. And then what we're returning is basically the LED level. So this is what I'm going to add here. Let's make sure we also map the signal called proximity here. So let's add a spline line and call it proximity, and its maximum access value will be 1023, and let's fix its values. Okay. As we notice the graph, there's nothing in front of my proximity sensor, or it may interfere a little bit with the cable, but as soon as I start putting my hand closer and closer to it, we're already receiving the signal. Okay, so that signal seems to only move to about 600. So that's the maximum that we have to take into consideration. And as I move my hand away, the signal decreases, the intensity of the proximity sensor decreases. So let me stop this for now. Go back to my visual programming tool, and then update the highest value here to, let's say, 630, so we make sure we're not out of bounds here. I'm actually going to go as far as 650 just to be on the safe side. So let's deploy it again. Okay, there's barely any signal on my proximity sensor curve. And now as I'm slowly approaching it, you can already see the first two LEDs light up. And then the third one, the fourth one, and so on. Until now, we're actually getting into the red zone. Okay, the last thing we could have done to make it really look like a parking sensor, let me just close this down here, is we could have also connected a buzzer. So it just so happens I have a buzzer here that I can connect. If you remember, this is pretty much like an LED. It just requires two pins. One of them has to be the ground pin. So I'm going to connect this one here and this one here. The other one has to get some signal from one of the other connections. So I'm going to connect it here and on pin 11. Just make sure it's the one with a tilde. Okay. In terms of modifications, what do we need to do? Just add a quick bit of logic here. So if my LED level, so go to variables, and if my LED level, back to a bit of logic, if my LED level is above 6, Just copy one of these and change it to 6. We need to do an analog write. Okay, so just go to pin access and do an analog write on pin number 11, which we just connected, add the value 20. Then add a quick delay from timing here. Let's say 200 milliseconds or so. And then make another quick analog write. Let me just move the function over a bit. On pin 11 with the value 0. These all depend on your buzzer, but these should be fine. I'm just going to add an else here just so we don't get stuck in this, and then copy over the analog write with the value 0. Okay, let's test the product. Okay, let's test the application once again. So the sensor isn't receiving anything. I'm moving a bit closer to it. The LEDs start lighting up. And then once I reach number 6, yep, there you go. Here you go again. Okay, thank you for watching this tutorial. We hope we see you again soon.